Okay, so we're starting second part for 12.2. This is going to be just focusing with regular polygons. And so if you remember, regular means that all the sides are equal. So my formula that I need for polygons is going to be in your formula sheet. And I have it right over here. For area, it's NSA divided by 2. So N stands for the number of sides. So here is 5 because there's 5 sides. Here N is 6 because there's 6 sides. S still is for side length, so whatever the length of your side is. And A is the apothem. Apothem is kind of like the radius for a circle because it's from the center to the side, but this is for polygons. So for polygons, it's from the center of the shape to the center of one of your sides. That's apothem. And so the first example that we're going to do is a basic one when all the information is given. So when all the information is given, all you gotta do is plug it into your formula and you will get your answer. So right here, I'm just gonna write NSA. Those are the pieces of information that I need. So again, N is the number of sides. So there's 1, 2, 3, 4, 5, 6. I count them. N equals 6 because there are 6 sides. So 6. Okay, S is the side length, and that is given to me. The side length is 9. So this is S, side length. This side right here, that would be 9. I'll do it in blue. This is 9. And then the apothem, that is from the center to the center of one side. So the 5 is the apothem. So then once you have all your information, you just plug it into your formula. So my formula for the area of a polygon is N times S times A divided by 2. So N is my number of sides, 6, times my number, or my side length, sorry. So times the side length, that would be 9. And then times the apothem, and the apothem's right over here, that's 5. So I'll multiply those 3 numbers, and then I'm gonna divide them all by 2. So then my area equals, so I'm gonna do 6 times 9, that's 54, and then times 5 is 270, and then divide by 2. So my area equals 135 inches squared. So this is my answer. Area equals 135 inches squared. Easy one, all the information was given. So what you're going to be doing more in class though, it's what to do when you're missing information, and then you need to find it to find the area. So to do that, again, we're going to start looking at things that you've already learned in geometry. So last semester, things you've seen in geometry. And so I'm going to look at examples 4 and 5 for that. So here I have examples 4 and 5. Okay, so to be able to do this, I have to first talk about what central angles are. So here I have a regular hexagon because it has 6 sides. It's a hexagon, and it's regular, so that means all my sides are equal. So I'm just going to put lines on all of them just to show that they're equal. Okay, right here the central angles add up to 360. That's because the central angles are right here in the middle. That's a circle. Circles always add up to 360. So to figure out So the first thing I'm going to do is I'm going to divide my polygon into triangles. So each vertex, I'm going to extend it to the center of my polygon. So the vertices are the corners. So each corner to the center. And once I do that, I have triangles. I have a total of 6 triangles. And so to find the central angles, these are the central angles right here. Each of those, to find those, I'm going to take 360, which should be the total, and divide it into the number of sides, because the number of sides is the same number of angles that I have. So I'm going to take 360 and divide it by the number of sides, which in this case is 6, because it's a hexagon. And so then I have 60 degrees. So each angle is 60 degrees. So I have 60, this one, I'm not going to label all of them, but all of them are 60, 60, 60, 60, 60. They add up to 360. So each angle for those triangles is 60. So now, to be able to explain what we're going to do next, I need to find just half of that angle, because I'm going to be using one more time right triangle. So if I draw a line straight from the center to the bottom, that's the apothem. Remember, that's the apothem. If I draw a line straight down, it creates a 90-degree angle right there. And so here I have my little square, my little right triangle, and I'm going to use that to be able to find my information that I need. I'm gonna have to figure out what this angle is, and you'll see why once I start working out the examples. But to figure out what that angle is, I'm gonna take the total, so it's 60, and I'm going to divide it in half, because there's 2. So half of 60 is 30. So this angle right here inside my right triangle is 30 degrees. So to divide, I just had to divide one section in half. So that's 60 divided by 2, that gave me 30. Okay. You'll see why once I get to the examples, but for right now, all I want you to know is that for any regular polygon, what you're going to do to find that angle right there is you are going to take 360 divided by the number of sides, and then divided by 2, and you'll get the angle that you need. Okay, so just remember this formula, and then you'll see why in these examples. Okay, so for my 2 examples, I used a hexagon just because I already know the 30-degree angle is going to be in the center right here. So right now I'm going to plug in the information that I know. So they're asking me to find the area, and I know the number of sides because I can count them. So there are 6 sides, so that's my n. I know my side length, it's labeled, that is a 4. So my side length 4, that's my s. And then the apothem is missing, so I have to figure it out, and here's where I'm going to have to use this little right triangle that I created. So I'm going to just draw that triangle in my picture. So I connect the vertex to the center. Now I have a right triangle, and I know that on the last section we were using a squared plus b squared equals c squared to find it. I can't do that this time because I only know the length of one of those sides. Remember, they're all 4 because it's regular, so all of these ones are 4, 4, 4. All this is 4. But since I'm only working with half of it, this part of my triangle is 2. So I only know one of the sides, so I can't use Pythagorean theorem to find A. So this is when we're going to have to use trigonometry, which was back in unit 10. SOHCAHTOA, sine, cosine, and tangent. So I already know the angle right here is 30. This is why we needed it, because we need it for trig. For trig, if you have an angle and a side, then you can find another side for your triangle, as long as it's a right triangle. So For this one, based on my angle, my 2 is going to be my opposite. So I'm going to label that. My 2 is going to be my opposite. Put O for opposite, it's across from the 30-degree angle. And since I'm finding the apotheme, that's going to be my adjacent. So it's right, the leg right next to the angle. You remember that's adjacent, so I'm going to put A for adjacent. And so O and A, if you remember SOHCAHTOA back in Unit 10, O and A is tangent. Just want to flip back to show you that. You remember when we were doing SOHCAHTOA, O and A, that's tangent. So you remember we had right triangles, and we had an angle and a side. We were able to use trig. That's why we have to do the same thing on today's examples. Okay, so I'm using tangent. So my formula for tangent, if you forgot, it's tangent of your angle equals opposite over adjacent. So I'm going to plug in the information that I know. Tangent of my angle, which is 30. Remember, I figured that out over here. This is why you needed it. Equals opposite. The opposite is the 2 over adjacent, which is the apotheme. So lowercase a for apotheme. Now I'm going to solve this. So you remember, I have to multiply by a first because I want to get rid of that fraction. So multiply by the denominator gets rid of the fraction. So I gotta do it on the other side. So times a over here. So now I have a times the tangent of 30 equals the 2. I'm not done because my goal is to get a by itself. So to get a by itself, I gotta get rid of that tangent of 30. So the opposite of multiplication is division. So divide by tangent of 30, and that cancels it out. And then I gotta do it on the other side. Divide the 2 by the tangent of 30. So now the a is left over, so I'm going to carry that down right here. And I'm going to divide 2 divided by tangent of 30. If you forgot how to do it, I'm going to show you right now. So remember, you still got to make sure your calculator's in degree mode. And I'm going to go to trig. I need tangent. First I got to type my 2. Okay, so 2 divided. Now I go to trig by tangent of 30. And you are rounding to the nearest hundred, so 3.46. Right here, 3.46. That's my apotheme. So right here, 3.46. And so now I can find my area. All I gotta do now is plug it into my formula. So if you remember the formula, NSA divided by 2. Number of sides, 6. Side length, 4. Apotheme is 3.46 right there. And then divided by 2. You just multiply that. You can do that in your calculator, and you get 135 meters squared. So this is my area. This is my final answer. Yes, it's a little bit of work, a lot of work, but tangent is something that you already learned last semester. The only thing that you're really learning right here is your apotheme and how to find that central angle that you're going to need. Okay, so example 5 is going to be a little bit different. So in example 5, still have a hexagon, so my number of sides is still the same, it's still 6. it's regular, so that means all of them are equal. My side length this time is missing, but now I have the apotem. The apotem is 4. I'm gonna just put that right there. This is the apotem. That's 4. So now I'm missing my side length. So still missing a side, so I'm still gonna have to create my little triangle like I did on this picture to be able to find my side length. So I'm gonna create my little triangles right here. My shape is still a hexagon, so that central angle right here, it's still 30. So right here, 30. Okay, and so I'm trying to find the side. So this is going to be the side that I'm trying to find. This part right here is opposite from the 30. So again, this is what I'm trying to find. I'm going to say this is x. So my x is the opposite side, and the apotem is still the adjacent side. So again, I'm still using tangent. For all of these problems, you're going to be using tangent. So that's one less thing you got to worry about. You just remember you're using tangent. So the formula is the same, and I'm going to plug in the information that I know. So tangent of 30 degrees equals opposite, which is x, over my adjacent, which is the 4. Okay, so same process that I did in example 4. I want to get rid of that fraction first, so I'm going to multiply by the denominator. So times 4 cancels it out, and I do it on both sides, so times 4 over here. So now I have 4 times the tangent of 30 equals x. Okay, this time is easier because I already have x by itself. All I gotta do is type this into my calculator, and I'm going to get my x value. So I'm going to put 4 times the tangent of 30. So here I go. 4 times the tangent of 30. Again, rounding to the nearest hundredth, so that's 2.31. So right here, 2.31. That's not my side length though, because right now I just found half of my side length. I want the entire side of my polygon, so I want this entire piece from this to this. I want the entire thing, so that part is twice my x value, so that would be like 2x. So then 2 times that 2.31, that's 4.31. Oh no, it's not 4.31, that's 4.62. So my side length is 4.62, and now I have everything that I need. So now I'm gonna go back to my formula and plug it in. So my formula is right here, NSA divided by 2. So I'm gonna do the work right here. Area equals N times S times A divided by 2. So N is 6, S is 4.62, apotem is 4, divided by 2. So once you type that into your calculator, you multiply, divide by 2, then you should get 55.44. This area, so it's meters squared. So this is your final answer.